If you look at problem 21, it's a part I explained in the previous lecture as well. It's a question asking what we call the region of low pressure during the propagation of sound. The correct answer is rarefaction, which is option C. When a sound wave propagates, there are two regions, one where the particles gather together and one where they spread apart. The region where the particles are compressed is called compression. The region where the particles spread out is classified as rarefaction. So, when the phrase low pressure appears in a sentence, you should interpret it as referring to this context. Conversely, when the phrase high pressure appears, you can consider it a keyword indicating compression. Let's move on and look at the next question. If you look at the sentence, it explains that calibration is performed to measure the propagation speed of the ultrasound equipment. So, what the question is ultimately asking is about the propagation speed that can serve as the reference value for the ultrasound equipment. Since ultrasound imaging applies the reference value for soft tissue, you can select 1540, which is in option 2, as the correct answer. Let's move on and look at question number 23. This question is related to the characteristics of propagation speed. It asks you to choose the change that occurs when the propagation speed increases as it passes through a medium. Yes, in the Physics SP lecture, I explained this as the law of speed. According to the initial letters of the law of speed, when the speed increases, the stiffness also increases proportionally. These two factors can be seen as having a proportional relationship. On the other hand, if you take the initial letters, you usually get density. In the case of density, since the spelling doesn't match, you can remember that it is actually inversely proportional. Returning to the question, since it mentions an increase in propagation speed, you should consider that the items in the options that can increase together are related to stiffness. So, you can select option A as the correct answer. As I explained with the formula, keep in mind that density, on the other hand, has the characteristic of decreasing. Next, let's move on and look at question 24. This is a question related to the frequency range of ultrasound. Since this is a question we've already solved earlier, let's go straight to the answer. For it to be considered ultrasound, it must be measured at a value higher than 20 kHz. Among the choices, the value higher than this is the 2 MHz in option C. Next, let's move on and look at question 25. I want to emphasize that this is a topic that frequently appears in questions of this pattern. If we interpret a sentence, it says that an obstetric ultrasound is being performed. Basically, in obstetric ultrasounds, since the mother's abdomen is somewhat protruded, there can be situations where the ultrasound does not penetrate well. In this way, when examining a large patient, this question is asking which transducer should be selected to minimize attenuation as much as possible. Basically, to reach deeper areas, you need to use a low frequency. The higher the frequency, the greater the attenuation, so these options would not be applicable. Although the reference value is somewhat ambiguous, since the clue large patient appears in the context of obstetric ultrasound, you should understand that applying the lowest frequency to select the deepest region is relevant. Therefore, among the options, you should choose 2.5 MHz, the lowest frequency, as the relevant answer. Next, let's move on and look at question 26. For this type of question, you just need to memorize the content through problem solving. This is also one of the patterns that frequently appear. It is asking about the factors that increase together when the frequency increases. Absorption can also increase. Scattering can also increase significantly as the frequency increases. Attenuation is the most fundamental. The higher the frequency, the less it can penetrate deeply, so all of A, B, and C are factors that increase as the frequency increases. So you should consider the option that includes all three as the correct answer. By working through this problem, you can also organize the relationships together. Let's move on and look at question 27. If you look at the question, you'll see that diagrams corresponding to option A and option B are provided. Sometimes, when additional clues like videos or images are given besides the text, people tend to find it a bit difficult. However, in reality, the more clues you have, the easier it tends to be to solve the problem. Now, if you look at the question, it explains that it is showing the propagation of a pulse. In the case of option A, you can see that the pulse travels for a longer distance. In such cases, you can say that the period is longer. As a result, this means that the opposing concept, frequency, is associated with a lower state. So compared to A, you can say that B is the opposite. Even visually, the period is shorter in B than in A. This observation strongly suggests that the frequency is significantly higher in this particular case. Keeping all of these specific assumptions clearly in mind, let's carefully compare every single one of the available options individually and solve the problem together. The question asks you to select the correct option. Looking at option A, it says that A represents a higher frequency than B. This can be considered an incorrect option. A actually represents a lower frequency, that's the characteristic of A. Looking at option B, it says that the waveform corresponding to B has a shorter period compared to A. Since this is a high frequency, it can indeed have a shorter period. Therefore, the correct answer would be option B. If you look at the next option, it says that A has a short wavelength. Compared to option B, here the frequency is lower, so the wavelength in contrast becomes longer. You can also see that it is connected in a longer way. Therefore, option C can also be considered an incorrect choice. Looking at option D, it says that A has even better axial resolution. This sentence is an important one. In the case of option A, when the wavelength is extended, the SPL also becomes longer. In such cases, it can actually lead to a decrease in axial resolution. Let me summarize this clearly once again. When the frequency decreases, the wavelength becomes longer. When the wavelength becomes longer, the SPL also increases accordingly. If the SPL increases, it actually results in a decrease in axial resolution. This is one of the most important concepts when studying ultrasound physics. When studying how far the influence of a single factor can reach when it changes, you need to pay close attention to this aspect. In the case of a transducer like a D1, since the frequency is low, the SPL becomes longer and the axial resolution actually worsens. Lastly, if you look at this option, it says that in the case of B, the SPL is even higher, but this is actually an incorrect statement. Compared to option B, option A has a longer wavelength, so you can consider that the SPL is also longer. Relationships like these can sometimes be difficult to understand all at once. So take it step by step and remember each part as you go. As you gradually expand your understanding and organize the content, I believe you'll be able to grasp the material better while solving problems. Now let's move on and look at question number 28. Since the sentence is long, let's start by interpreting it. It says that a hepatic sonogram is being performed. It is subjectively described that the patient has fatty liver. Because of the fatty liver, the ultrasound beam is scattered more and problems can occur during the transmission process. It is explained that the posterior lateral lobe of the liver, which is in the back part, is not well visualized. In this situation, the question is asking which equipment adjustments are needed to better visualize this area. Ultimately, since the patient has a larger body size and there is a lot of scattering and attenuation of the ultrasound beam, the question is about finding the adjustment factors that compensate for these issues. The correct answer would be option C. If you lower the frequency, as we discussed in the previous question, the scattering will also decrease. Additionally, since it allows penetration into deeper regions and the posterior right lobe of the liver is a structure located in a deep area, this equipment control will help expose that part more effectively. This is a pattern that asks about both basic physical concepts and their clinical applications. I can also say that this type of question is a common pattern that appears frequently. Next, let's move on and look at question 29. This is a concept related to the speed that can occur when an ultrasound beam passes through bone. For this, you need to memorize a few standard values. In the question, they asked about the speed value for bone. For bone, you should remember a value close to 4000, which corresponds to option D. The value of 1540 in option C is the standard value and corresponds to soft tissue. The value of 333 in option A represents the speed when passing through air, so keep that in mind. If you remember these representative propagation speeds, it will make solving this year's problems much easier. Let's move on and look at question number 30. This question is about finding the sentence that defines the speed of sound. Rather than solving the problem step by step, it's more efficient to directly find the correct answer and organize the concept. Speed of sound. If we choose the option that best describes the speed, we can select option B from the sentences. The speed of sound refers to the speed at which a sound wave propagates through a medium. If you remember this sentence, you'll understand that the definition of the speed of sound can be interpreted in this way. Rather than overthinking and solving the problems that way, I would advise you to find the correct answer directly and review the content.